This is Semester 2 Exam Review, Chapter 14. We're going to use the sine function to write an equation that has an amplitude of 4 and a period of 1 over 3. So first, we think about it as our sine function. If it's going to have an amplitude of 4, you know you're going to have a 4 sitting in front. If the period equals 1/3, there's a formula to calculate period, 2 pi over b. The b value is what sits in front of the x. If the period is going to be 1/3, we would multiply by the b, essentially cross multiply. So b equals 6 pi. So our equation is going to be y equals 4 sine of 6 pi x. We're going to describe the shift that's happening with this sine function. Y equals, typically it would be a sine of b x minus h plus k. There's no amplitude, no vertical stretch more than 1. The period stays the same, but in terms of our shifts, the h and k determine that. It's going to move pi to the left, because remember it's the opposite, and 1 unit down for the k. Pi units left, 1 unit down. We're going to find the maximum and minimum points of this equation. A great way to do that is to look at the graph. So we know that it's a sine graph, and that starts at 0, has a maximum, 0, a minimum, and 0 again. Then we're going to do a reflection and stretch it by 2. So instead of going up and around, it's going to come down and up twice as far. The b value helps you determine your period. The period equals 2 pi divided by b. So we're going to figure out that the period equals 2 pi divided by 2/3. When you multiply by the reciprocal, we identify that this period is going to be 6 pi divided by 2, which is called 3 pi. So we know out here is 3 pi. To determine what each of our increments are going to be, we're going to take the period and divide that by 4. So we're going to take our 3 pi and divide that by 4. So this first spot in our graph is 3 pi over 4, then 6 pi over 4, 9 pi over 4, and 12 pi over 4. 12 pi over 4 would be the same thing as 3 pi, so that's a good way to calculate if your period and increments are matching. So now we know what our units are going to be in terms of the x. We know what our minimum value is here, 3 pi over 4 comma negative 2, and this is 9 pi over 4 comma positive 2. But before we have our final answer, we need to look at what type of translation that there might be. Notice that in our graph, our h value is pi over 2. So the graph is going to move to the right pi over 2. So our final graph is going to land pi over 2 to the right. So we're going to add pi over 2 to 3 pi over 4. Pi over 2 can be written as 2 pi over 4, so we have common denominators. So our x value will now be translated pi over 2 to the right, which is 5 pi. This is a minimum value. 5 pi over 4 comma negative 2. Then we're going to go to our maximum value, and we'll take our 9 pi. So we're taking our 9 pi over 4, and we're going to add the pi over 2 because it's being translated to the right. So we're going to call that 2 pi over 4, so the units, the denominators are the same. 11 pi over 4. So our maximum value is going to move to the right, and it's going to land on 11 pi over 4, and it's up 2 units. That was a tricky one. Number 4, what is the period of this graph? Well, the period is the x value that it takes the graph to go all the way through the cycle. The cycle is considered the portion of the graph. The period is the x value that the cycle takes up. So the period, as we've talked about already, is 2 pi divided by b. We see here that the b value is 1. So the period is just going to be 2 pi. To graph these, very similar to how I made a sketch of our equation in number 3, we see that this is a sine graph. We would start our sine graph out. This would be our parent function. And then it would be stretched up 4, stretched down 4, see a mistake already. It's going to maximize here, it's going to come to there, minimize, max. So this is going to come right through that same point. And then back up. Now we got to figure out what our scale is going to be. Our b value. So we have 2 pi divided by pi. So we're left with a period to equal 2. The increment is going to be the period divided by 4. So the increment is going to be 2 divided by 4, otherwise known as a half. So this is going to be a half. This is going to be 2 halves. This is going to be 3 halves. And this will be 4 halves. Also known, 4 halves is the same thing as 2. There's no translation here, no parentheses. So our x values, when we're at we start with 0. When we're at 0, we're at 0. When we're at a half, we were up at 4. When we were at 1, we were at 0. When we were at 3 halves, we were down at negative 4. And when we're at 2, we were at 0 again. So you would want to write the name of the graph on your name of the equation on your graph. So let's try it again. Start with cosine. This time I'm going to look ahead and I see that my a value is a half, so I'm going to have to shrink this up. So I'm just going to say that 1, 2, 3, 4, we're going to call that 1. We're going to call that -1. In a sense, we're kind of zooming into the graph. So we're going to start at 1, and the cosine graph curves down to 0, down to -1, up to 0, up to +1 again. The half is going to make it be half as far. It's going to shrink it in. So we're going to come down, round, up and over. And then our period is 2 pi over b. We see our b value is 3 over 2 pi. The pi's cross off, we multiply by the reciprocal, and we get 4/3. So we know out here is 4/3. So we'll have our 4/3. That's how far the period is. That's how far the cycle takes to go through the entire graph before it repeats itself again and again and again. And the increment is the period divided by 4. So the increment's going to be 4/3 divided by 4. So we're going to take our 4/3 and multiply it by 1 over 4, which is 1/3. So this is going to be 1/3. This will be 2/3. This will be 3/3. And this is 4/3. So it's a good way to test what your period is if your increments help add up to it. So at 0, we're up at a half. At 1/3, we're at 0. At 2/3, we're at -1/2. At 3/3, which is 1, we're at 0. And at 4/3, we're up at a half again. We should talk about the domain and the range. The domain, we know that the sine and cosine graphs continue on forever. I'm just graphing out one cycle, but they do continue on with that same pattern. So it's all real numbers. It goes both directions. The range, we're going from a half down to -1/2, or we would often say -1/2 up to a half would be our range. For this graph up here, the domain, the graph goes on forever, right and left, so it's going to be all real numbers. And the range, we're going up to 4, which is your amplitude, and down to 4. So we have -4 is less than or equal to y, which is less than or equal to 4. Last question. We're going to graph the sine graph. So I'm going to start at 0, 0. Typically we go up and back to 0, down and back to 0. That's what the basic sine graph would look like. We're going to have a reflection and a stretch of 2. So we're going to come down by the reflection and we're going to multiply that by 2. It comes down twice as far. This one's going to have a reflection and get multiplied by 2. The 3 is your b value. So to help determine what the period is, 2 pi over b. So the period is going to be 2 pi over 3. 2 pi over 3. The increment is going to be that period divided by 4. Well, that's 4 over 1. So we're going to take that and multiply by the reciprocal. That would be 2 over 12, which is pi over 6 with some reducing. So we have a pi over 6. We have 2 pi over 6, which would reduce to pi over 3. We have 3 pi over 6, which is pi divided by 2. So we have before I put in our graph here, our table, the graph is also going up, has a k value here. It's not in parentheses, so I know it's not the h value. The k value is exactly what it says, positive 4. So we're going to move this up 4. All the main points. Move up by 4, and don't forget we like to write the equation. I'll go back and add the equation for the last graph. So where are we at? At 0, we're up at 4. At pi over 6, we're at 2. At pi over 3, we're up at 4. At pi over 2, we're up at 6. And at 2 pi over 3, we're at 4. This equation, this graph never got the equation written for it. Y equals 1/2 cosine 3/2 pi x.